1 2 1 2 1 2 1 2 1 2. Woo!
Hello guys, and welcome back to this one. So today we are going to be looking at the debugger tool illustration for the brute force solution, and we are going to be looking at how we move these sorted lists to a single sorted list, and we basically merge the sorted lists, right? So yeah, we are going to see the values go through the code or the system, and one after the other we begin to see how they begin to form into a sorted list or a singly sorted list. Yeah, so let's dive into it. Okay, yep, why are we going through every guy? Okay, now we step into it, and yeah, we have our files. It's a list of a list, and it's basically well illustrated here. And then we say while true, we define the smallest value, we define the smallest file as none. Now, so obviously here we've defined indexes, so we could see our indexes has been created 0 0 0, and then we've checked if indexes at this specific position is I wanted it to show me this guy right here for some kind of explanation, but yeah, let's move forward for now. But yeah, we can see that the current file, if we look at we haven't matched through yet, so when we step through, do we get current? Now you see current here is 1, because what it checks file index. Our file index, we could see that our file index is 0, so because of by the first instance our files is 0. Files at the index of 0 is this whole block, right? And then file index at the index of 0 as well is still 0, so we could see it here. And then we could see that we are pointing to 1, so we could see that current is 1. So we say if value is none, so value is none right now, so value should be updated on a real time to 1, and then file would be updated to 0. So if we could take that real time as well, it remains 0. So we can see here file is 0 and 1 is 0. Now the for loop continues. So here we check for the indexes again. So yeah, this is what I wanted us to see, so that we understand what the file, the index of the file index, right? Kind of see that is what at 1 is still 0, and file at this is 3. You can see that the length of this file here, you see here that the length of the file is 3. So basically 3 against 1 against 3. So we see that conditional does not succeed. So we continue in the system, we get current again, and this time around current should change. You see that current is now pointing to 3, right? Which is this first guy on the second list in the table. We could also see that here as well, right? The first guy on the second list, and then we compare it against the smallest value, right? If that's the smallest value is not known, we just compare it against the smallest value, which is 1. So we see it here, smallest value 1, current value 3. So smallest value still remains 1. So we will jump over that. Now we go through the stuff again, and now we'll get current to be something 7, which is the first guy in the third list. So we could see the pattern now. That is, it will capture the smallest value and then go through all the lists to see if its forefront value, matches what we are looking for, matches or is lesser than the smallest value that we already found. And if it's not, then at the end of the day, after going through the for loop, it will come here and check, if the smallest value is none. That's if the smallest value is none. That's the only case the smallest value is none is if it's never updated, right? So meaning that we didn't find anything in the lists, right? Then we break. But yeah, that's the condition is not met because we have 1. Smallest value is 1. So we print it out, and then we'll go ahead to then increase indexes, right? At the smallest file. Smallest file is talking about the file where we found the smallest value, which was the file at the index of 0. So we take that the smallest file is 0. So indexes at the index of 0 is this first guy. So we increase it to 1. So press true. Okay, I don't know if we have okay, so we have indexes. So we can see that indexes immediately becomes that first index becomes 1, meaning to tell us that our next file that we're going to be looking for in this first list is now going to be 2, because we have handled 1. So that's basically the algorithm in a nutshell, and we're now going to continue doing that and continue doing that going through every list, printing out the smallest, going through every list, printing out the smallest at every instance. And at the end of the day, we get our values printed out, all sorted. So let's just now, speed up how we go through the list. Now we've understood the logic even clearer with the debugger tool. So now we continue, we instantiate this as none again and make smallest 0 again, and then we continue. We check if it's up to 3. Basically index is at 1 at index of 0 is now 1, but it's not yet up to 3. So we jump over, current becomes 7, right? Okay, that's what current was before. So after matching 3, then it should become 2. So we see it becomes 2, right? It is gone to the next file in that index. So it skipped over 1 now because we popped out 1, and we told the file index that 1 is out by updating this guy over here. So when it checks the index now, it's going to readily remove that, move to 2 rather. So we can then go through it, update smallest value to 2. Now we're going to check if we see anything greater than 2 again. So the next one is 3, so it's not less than 2. The next one is going to be what? Next one is 7, so that's not greater than 2. Let me zoom in a bit. That will help us to better see the stuff. So we can see here that 7 and this is 2, right? So yeah, if we could zoom in some more, a little better clarity. You can close this a bit. The clarity of what's happening, right? Now we go again, and now the for loop should be done. So we are out. We have a smallest value, so it's not none. So we print out 2, and then we increase that guy, which is the indexes at that first distance. We moved it now to 2, which is the last guy on that list, which is 5. Now we continue again. We reset everything back to its base, smallest to none, and this guy again, and then we go through it. We get smallest value and point it to 5, and we point this guy still to 0 again because that's where we find the smallest value right now. And then we continue the for loop. The next guy that will challenge 5 is 3, but 3 is less than 5, so it will take the top spot immediately and becomes the smallest value, and 1 now becomes the smallest value because that's where the file at the index of 1 is where we find 3. So we just continue. Who challenges 3 again for the smallest spot? 7. So but 3 still wins. 3 still wins because it's greater than 7. It's less than 7. So we are done. We pop out 3 and we increase these indexes of that file to 1 because now because 3 came from the second file. So we continue again. That's why we just move through it until we get our value. Now we've updated to 5. What challenges 5? 4 challenges 5. 4 is still less than 5, so 4 takes the top spot. It takes the spot again, and then 7 should challenge 4, but 4 is less than it, so we print out 4 again. We go again, we reset everything. Now we have 5 as the current. Now someone will challenge him again, challenge 5 again. This time around, that's 10. 10 challenges 5, but 5 is less than 10, so it gets to win that fight. And yeah, we are done because 7 also challenged, but 7 could not win 5, so 5 gets to be popped out, and then we continue in that bit. And that's basically the idea of what's happening here. We are just popping out these values until we are done, basically printing out the whole list again. So yeah, that's the algorithm, and this is the debugger illustration. We could see that the indexes keep rising. Now we have resulted the first one because we have 3 of 3. So every time we come in here now and we hit this first value here, we see that indexes is equals to 3. So we can see here that we have the file index of 0, right? So when we compare indexes at file index of 0, we get 3. So we can see here now that's 3, and that is greater than or equals to the length of the files, which is also 3. So we'll see here that we're going to have to continue. So we see we'll continue, and then basically we just go through that. We will now see all this. We'll see these ones fill up slowly. So you see that 322, and because we just printed out from the third list, and then we should have another one very soon. So my eyes is on this indexes file. We just go through it. Now we have 3. We've printed out 3. So the last value, which is 10, which we obviously know is coming from, right, that's the second list. So that's where the last one is going to be popped out from. And by the time we do our control, yeah, we can see that we've printed out 1 through to 9. So basically 10 is the last one, and when we print that out, we get our fully sorted list. So that's basically it for this one. Hope we are able to see, how it transverses and how we have this value. And yeah, we could then we've crystallized now, the idea of sorted files into a singly sorted list. And yeah, we are done. So that's basically for this illustration. Next up, we're going to be looking at the complexity, and yeah, we're going to be discussing the time and the space complexity. See you on that one. Muchas gracias. Bye.